how nervous are you for the first test? All right. So hopefully, so I will tell you that it's a psychological thing. The more you're nervous, the worse you're going to do on the test. Okay. So hopefully, after today with the review, I will take some of those nerves away. That's the goal. If I'm going over something today and you don't get it or there's something, ask. All right. If you have to look something up in your book or your notebook and stuff like that, that's something mark. Write that down in your index card. Because odds are you're probably going to have to look that up. You need it on Wednesday for the test. Okay, so those are the things that you should be writing down in your index card. Things that, like, just little notes like, all right, remember to do this. The questions in the this that I'm going to go over are in the same order as the questions on the test. They're very similar to the questions on the test. I just changed some numbers. Okay? So if you can do this, you should do fine on the test on Wednesday. All right? The first question on the test, the first question on the homework, and the first question I'm going to go over is probably the hardest question of the entire thing. And honestly, it's really not overly hard. It's just a ton of calculations. Okay? So the first question asks you to find the tangent line. And on the homework assignment, it gave you, there's like, I think like 6 or 7 steps you have to do on this one. The test will actually be very similar. It's going to be 2 tables that you have to fill out and then a couple questions at the bottom. So that's what we're going to look at. The first table actually has you finding the points. So we're starting at the point is 5, 1. So the table is going to be set up like this. It'll be 4.9, 4.99, 4.999, 5, 5.001, and 5.1. So it'll have like 7 things that you have to plug in. For this step, all you're doing is plugging that number into the equation. So you're literally going to do 2 divided by 7 minus 4.9. And I would use Desmos for this. I would actually use the graphic app, or your calculator is fine, whatever one you have. So, because you want this as close as you can. So when you're doing it, you'll notice, so that's 4.9. I'm going to write these numbers down in a minute, but 4.99, 4.999. You'll notice the numbers stay pretty close. So when you're writing the number down, if you're going to write it as a decimal, you want to write it out to probably about 5 or 6 decimal places. Okay? Because you're going to need to use this number in the next step. If you want to write it down as a fraction, you can write it down as a fraction. That's one of the nice things about Desmos. You can just click that and get it as a fraction. This way you have the exact number when you plug it in the next step, which probably make your life a little bit easier. And honestly, the decimal is probably easier to write than 6 decimal places. So 4.9 comes out to be 20 over 21, 4.9528380, or 1. You can put it in either direction. It doesn't matter to me. Because you're going to be estimating in this problem anyway. So when you write the final answer, you're getting close to a thing anyway. You're going to be able to figure it out fractional-wise or decimal-wise. That doesn't make much difference. Just if you're going to do your decimals, you want to do it out to 5 or 6 places because you're going to need those places at the end that really show any difference in the problems. So I'm going to write them down as decimals or fractions just because I think it's actually easier to write. But so I'm going to do these 3 and then I'll switch back over and I'll show you what I'm writing down. So you see I'm just writing those numbers right in the table. If you plug 5 in, what should you get? You should get 1. That's the point I gave you. And if you're looking at these numbers here, you'll notice they're getting closer and closer to 1. Okay. All right, now let's do the other side. So we have 1. And you notice they're just on the other side of 1. That's 1/19. So that's the first table that you're going to have. Yes. Oh, you need to use the scientific one, not the graphing one. There's 2. If you're downloading the app, there's 2. If you're going to the website, just click on it and make sure to pick the scientific calculator one. Yeah, the graphing calculator will leave it as a decimal. All right, the second table is your slope table. And this is, I think, where most people are having trouble with the homework part. The slope one is literally using the slope equation. What's the slope equation? No, that's the slope intercept form of the equation.
Y minus y1 equals x minus x2.
Close.
y1 minus y2 over.
Yeah.
And it actually doesn't matter 1 or 2 as long as they're both the same. So it's y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. As long as you do the same order, it doesn't make a difference.
One of the y's is
Right. That's the thing. One of your points is your original point that you started with. The other point are the points you have here. Okay. So to find my slope for this one, we're going to use this point here and the 5, 1. What do you mean? Yeah, but it's going to make your life a lot more difficult. In this case, all you want is the slope. You don't want the equation yet. So here's an easy way of setting it up. That's what you have the formula there. My first point's 5 and 1. That's going to stay. And now I'm just going to plug in the other points that I found. So it was 4.9 and 20 over 21 was the first point. And that's my slope, is 10 over 21. Okay. Does that part make sense? Yep, you're using the 5, 1, the original point, and you're using the point that they gave you, that you found. Because in essence, we're looking for the tangent line at that point. So we're looking at how the slope's changing as we're getting closer and closer to that point. So my first one is 10 over 21. And now we change this to 4.99, and this was 200 over 201. And we get 100 over 201. 99. And we get 1,000 over. Yes. Yeah. Yeah. You're going to see the same concept if you do it in decimal form. Yes. Yeah. So it's going to look like this. You're going to have two tables on the test. And you're going to fill the points in, and then you're going to do the slope on the one afterwards. And then you're going to tell me which the slope's going to. And then you're going to come up with your equation. This is probably the most important one. If you put in that, you get undefined. Because you're dividing by 0. It's actually 0 over 0. So this slope, the one in the middle, because can you find a slope at a single point? No. That's where we're using the limits. We're getting closer and closer to it from each side. That's what that limit is helping me do. And now we do the other side. And 100 over 199 and 10 over 19. So looking at those numbers, what do you think the slope's getting closer to? 1/2. Okay. And if you were putting them in as decimals, you should see the number on one side getting like 0.499999 and then 0.55, 0.500001, things like that afterwards. So again, it's getting closer to either 0.5 or 1/2. So after you've done the table, the next question is going to ask you, what is the slope getting close to? And in this case, so after we've looked at the whole table, don't worry, it's saved on the other slide. It's not going away. So my slope is going to 1/2. Yes.
On the homework, it says using the slope part B, find an equation.
That's the next step I'm going to do right now. That's the point right there. Once you finish the slope, your slope is now 1/2. So that's M. Now you use the y equals mx plus b. And we're going to use that as my point. So I have 1 equals 1/2 times 5 plus b. So b equals 3 over 2. Or negative 3 over 2. So it's going to be y equals 1/2 x minus 3 over 2. And that is your final answer. So here is what that is. So here's my original equation. And that's the tangent line. It doesn't touch the equation anywhere except for 5, 1. And there's that. That's the tangent line. Yes. Oh, yeah, I'm going to go back. Yeah, that was my point. So we're in essence using what we did where we're looking at as limits, the numerical method of limits, finding it getting closer and closer. to find that slope piece. And then once I have slope, I can use it to find the y equals mx plus b, which everybody remembers. Each question there's 10 questions on the test. Each one's worth 10 points. Okay. So this question is worth 10 points. Some of the other questions that are going to be a lot easier are also worth 10 points. I don't differentiate between the questions. Okay. So there's a bunch of parts to this question. So if you get most of it right, you're going to get probably most of the points on it. But don't sit there and stress completely out about this one. Like, it's going to be the first question on the test, unfortunately. You can skip it, go do the other questions, and come back to it at the end if you're really struggling with this question, but you know the other ones. So, yes. So if we look at the table, these might be a little easier to look like as a decimal, but like this becomes like 0.49, 0.4999, and 0.49999. It's getting closer and closer to 0.5. Same thing when you're looking at these, 10 divided by, it looks like it's getting closer and closer to basically 1,000 over 2,000, which is a half. Same thing on the other side. Huh? Yeah, it's, so if I look at, that's the point of a limit. If I'm looking at it coming from both sides and they look like they're going to a specific value, that's the value at that point. So these look like they're going to 1/2. So that value right there that's undefined, I can make the understanding based on limits that it's going to 1/2. And then the nice thing is looking at the graph, you can verify that. Once you got your equation, you can plug it in there and say, oh, yep, it literally hits at that one point. So you can use Desmos at the end to verify that your answer is correct. If it hits it at more than 1 point, you probably messed up. Okay? Because like if I change this to 3/4, for example, the slope's right, but it hits it at more than 1 point. So obviously something's wrong. Or what I did when I screwed it up and forgot my sign before I changed it. Plus, well, that doesn't make much sense. Oh, let me change my sign. Oh, that makes sense. So it's like you can use this to verify your answer at the end before I even correct it to see if you got it right or wrong. Okay. All right. Any other questions on that one? Okay. Next one. So you're going to have a graph similar to this. And it's going to have, I think there's 6 parts to it. Those two, let's see. 1, 2, 3, 4. Let's do 4. Let's do this 3 first. All right. So remember the symbols. If it's for negative, we're coming from the left. For positive, we're coming from the right. So we're going to 4. So in this situation, we're looking at that section right there. So if we're coming from the left, we're going to what? 2. If we're coming from the right, we're going to 2. So since they both equal the exact same amount, that means the whole limit equals 2. I'm not sure if this question asks it or not, but we'll put it in there just in case. What's f of 4? 1. Okay. Is there a discontinuity there?
Yeah.
What is the discontinuity?
like the type of discontinuity?
Yeah.
Removable. So what's that?
This one's removable. Yeah. Yes, the other one is the jump discontinuity. So yes, there's a jump discontinuity, and then there is a removable discontinuity. This one's a removable one. No, you will not need. I don't think I have that on. I didn't think I asked that on the test. Oh yeah, I did actually, but not in this question. On a different question. All right. Let's keep this slide. So I want to do the other one. All right, what's the limit as this function goes to -3? Yeah, if we're coming from the left, we're going to -2. If we're coming from the right, we're going to 0. So what is the limit as it goes to there? It does not exist. Remember, they have to go to the same value for that limit to exist. So this one, that's your jump discontinuity. What's the value of f of -3? -2. Okay. This question on the test has 5 points. So it's basically like this. Two questions down. Are we feeling a little better? Huh? No? You're allowed to still say no. Yes. It's the point. It's the solid point. You're looking for, if they were both open points, it wouldn't exist. But since this one is a solid point, that's the value that exists at that number. Same thing with this one over here. It was 1 because that's where the dot is, not 2, even though it's where it goes. Okay. All right. So there's 7 questions on the test that are just this. Okay? Just find me the limits of something.
And you can plug it in.
Well, yes. Not always going to give you the answer you want, but yes. All right. So this one, yes, you can just plug in the number. That should be the first thing you try. All right. Always try, plug in the number. And this one, you absolutely can. So this ends up going to sine of 0, which is 0. Okay. This question is worth the same as this question. Okay. Yes. Yes. I changed little things in them, but it didn't make them drastically different. Yeah, things like that. Like that was literally like little things. Like honestly, this first equation was the same thing. I just did a different point. So I used 5-1. The test uses a different point on the graph. Same process though. So, okay, so it's literally little changes. All right, let's look at this one. They're not. I'll just plug the number in. So what do we got to do with this one? Yeah. Yes, this one I got to do my conjugate pair. So what is my conjugate pair for this one? Right. So I'm going to multiply the bottom by x plus 2 plus 2. And the same thing on the top. So my top comes out to be 2 minus x, square root of x plus 2 plus 2. And the bottom comes out to be x plus 2 minus 4. All right. Can I plug the number in now? If I plug in 2, what do I get? I still get 0 on the bottom, right? All right. So we've got to somehow simplify this problem now. So if I change, let's clean up the bottom a little bit. I can change this to x minus 2. This here and this here look very similar. What's the only difference? Yeah, the signs are different, right? So if I change this to minus 2 minus x, are those two the same thing? Yeah. So I didn't change it. I just pulled out a negative sign, basically. Yeah. So now I have 2 minus x, square root of x plus 2 over negative 2 minus x. So now I can cross off those two. And this becomes the limit as x goes to 2 of negative square root of x plus 2 plus 2. X minus plus 2 minus 4 gives you x minus 2. Were you going to ask the same question?
That's why I was so.
It's because the number didn't change. Like it was x plus 2, then becomes x minus 2 since the number didn't change. It's like, wait. If the number changed, you wouldn't have asked that question. It would have been obvious. But since the number stayed the same, but just the sign changed, yeah, it gets a little tricky. So yeah, now we got to plug in. Now we can plug in 2. So we get 2 plus 2. So this limit goes to. So it goes to negative 4. So, and remember, you can always use Desmos to check your work. Here's just the original equation. If we're looking at this, I think my answer was x equals 4, right? Oh, sorry, wasn't it? Yeah. Oh, and it was y. It was y equals negative 4. And that looks like it fits there. That's where it hits the graph. And if I look here, it is undefined at that point, but it's right there. So I'm good. That's the right answer. So you're going to have a problem that has to have to deal with conjugate pairs. You're going to have an equation that deals with the piecewise function. All right. So what's the limit as x goes to 1 from the left? So when you're looking at this, you have to figure out the key with the piecewise function is figuring out which part you're going to use. Okay. So let's block off the bottom for a second. All right. So this one, we're going to use x because x is less than 1. That would be the values that are coming from the left. Does that make sense? So in this case, the answer would be 1, because if you plug 1 into x, you get 1. I wouldn't use that one because that's where it equals it. And I wouldn't use that one because that's the one that's coming from the right, because that's when it's greater than 1. Confusion. Which part? All of it? All right. So this is 1 to the negative. So that means I want to plug in numbers that are less than 1. Because this one?
Yeah.
Because x is greater than 1. So we're looking for values like x is 0.9, x is 0.999, things like that. And that would be here.
Less than?
Right, less than 1. We want x, because remember, we're looking at it. I'm just going to use this graph real quick. I'm going to show you the answer in a second. We're just going to use the graph. So we're looking at, remember, we're coming from the left, so we're coming from this direction. Those are the negatives. So since I'm using that first one, I just plug in that value to that equation. Because I can plug in 1 to that equation to get the answer. So the answer is equals 1. Now this one is looking at it coming from both directions, correct? So currently I have, as x goes to 1 from the left side, that equals 1. I did that. So what happens as I come from the right side? That means I'm going to use this equation, correct? Because that's the greater than 1. So let's plug 1 into that, see what happens. So 2 minus 1 is, that's 1. So they both go to the same number. Therefore, my limit goes to 1. If they went to two different numbers, then the answer would be does not exist.
So we, in that case, gonna do the 2 minus squared. Because it has the left and the right, or it has 2 different.
No, I'm doing this one because of that.
Because it has 1.
Right. Because that's the greater than one, and that's the less than one. So I have to do both those. What's the value at one? So that answer is 3. Questions with that one before we do the other 3 parts?
On the test,
Yes.
you want us to like write out like for like the second one, or we wrote out X to 1. as a- We just put
You could just put 1. However, if you get it wrong, I don't know how you messed up, so I can't give you points. If you did both, and I could easily catch the mistake, you might get some points. So the real key comes down is the more you write, the better chance I have to give you points. So, all right, let's look at this one. So if I'm coming at 2 from the left, which one am I using? I'm using the third one because that's this part right here, right? That's coming from the left. That's the less. So if I plug in 2, I get 2 minus 4, which is -2.
Question.
Yes.
What's that symbol there that you circled?
This x is less than or equal to 2.
Okay, I didn't know that was an equal.
Yeah, if the line underneath, so depending on how the book does it, sometimes it'll be a slanted line, sometimes it'll be a straight line, but it still means the same thing. All right. If I'm coming from 2 to the right, which one's that one? That's this one, right? So 2 minus 3 is -1. So I'm going to use that one. So that's the right. That's the left. So what is the limit? Does the limit exist or no? Does not exist. Because they do not go to the same place. All right. Questions on that one? I think that was 5. Yeah, that was question 5. 5 more to go. Yep.
You said the top to the quadratic formula with the piece really at the 6t squared plus 5 minus what you did the top of that. Maybe look perfect, we be able to do the quadratic formula from there.
So what's the quadratic formula going to give me? Okay, but no, that wasn't what I was asking. What information is it going to give me? Yeah, it's giving me a 0. So it's giving me where the equation crosses the x-axis, right? Is that what I'm looking for here? No. So that wouldn't help. You could use the quadratic formula if you wanted to factor things out. If you did the quadratic formula on the top and the bottom and you found a value that worked for both of them, that was the same, you could use that to factor things out. If you couldn't just look at it and say, oh yeah, I'm going to factor this piece out. That's possible. But that's not what this is asking. So how do we do this one? Yeah, this one you could use your pre-calc brain if you want. If you're looking at the highest degree on the top and the bottom, you have 6t squared over negative 2t squared. So 6 over negative 2, which is negative 3. That's the pre-calc brain. Yeah. Remember the calculus brain? What do I have to divide them all by?
T squared.
Right, the highest degree in the denominator. So I'm going to divide everything by t squared. So which gives me 6 plus 1 over t minus 5 over t squared, 9 over t squared minus 2. And now remember the limits, everything over an x1, they're all going to go to 0. So that goes to 6 over negative 2, which is negative 3. Both come out to be the same.
That's the region of it.
I don't care which way you use. But remember, this only works for rational functions with polynomials. Once you deal with anything else, you're not going to be able to use that method to do it. So, will there be one like this on the test? Yes. They won't all be like this. Just like the first question was like, you plug the number in, you're good. They weren't all like that. In this case, does the negative infinity or positive infinity matter? No. Because this one has the one horizontal, it goes out to both directions, it's going to the exact same value. So it didn't matter, negative infinity or positive infinity, that doesn't change the process that I'm doing here. And you can always, again, notice I didn't do it for the piecewise function because that's a pain in the butt to graph, but using Desmos, you can always check your work. Just, you have to use X and not T. So if you look at here, I said y equals, what is it, negative 3? And yeah, that looks pretty much, that looks right. That looks like what it does going out further as it goes out. So remember, you can always use that to check your work. All right, this one. I don't think I've ever seen a card 5 by 12, 4 by 6, or 3 by 5. I'm like, if you can go to the store and find me a package that says index cards 5 by 12, you could use one. Now that I said that, I'm gonna actually do a quick little search here.
Yeah.
3x5, 4x6. I did see a 5x8. 5x8 is the biggest one I can find. That actually says index card. Honestly, you're not going to need one that big. You can use both sides. So you really shouldn't need one that big. All right. I guess it depends on how big you write. All right. What am I gonna we're going to infinity. So one of the methods that we showed is dividing. So what am I going to divide them all by? Let's divide them all by x. See if that helps. Sometimes it's going to help, sometimes it's not. But that's always the first thing to try. So I'm going to divide everything by x. So my top looks like that. How am I going to put that x inside the square root? I'm going to make it the right. That's going to be over x squared. I have to bring it back inside because the square root of x squared would be x. So that doesn't change anything. So I'm dividing the top by x. I need it under the square root. Otherwise, I can't do anything with it. So to move it under the square root, I have to square it. Because the square root of x squared is x. So that doesn't change the problem. If it was the cube root, I'd have done x cubed. Again, it doesn't really change anything. All right, so my top now becomes the square root of 2 plus 1 over x squared. And the bottom becomes 3 minus 5 over x. So it goes to the square root of 2 over 3.
Because what was the column with the 0 thing?
Yeah, the limit as anything, a constant over a variable goes to 0. So the limit as 1 over x squared goes to 0. That's why dividing by x, those things help. So the rule was,
Equals 0?
yeah, the limit of as x goes to infinity of 1 over x is 0. And it's actually 1 over x to the a. Whatever a happens to be would work.
And you're okay. 3 over 2, we don't turn that into that, but that's what we're doing.
Nope, I would rather that than a decimal.
That's one of my new.
Oh, that little rule?
Yep.
Good rule to remember.
Is that only for when it goes to infinity or it could be like negative?
It would still be the same, yeah. Negative infinity is still going to come out to be 0. Because as the bottom gets infinitely more negative, it's still going to 0.
Okay.
It's just going to 0 from the negative side. Yes.
Can you just go back?
Oh, sure. No problem. What about this one? Can I? If I'm making it a fraction, I have to divide. The only way to divide something is I have to also multiply it by, right? So these, when I divided, I've divided the top and the bottom by the same thing. Therefore, I don't change anything, right? You can't change the problem. You can manipulate. So if I was going to divide this by something, I would have to multiply it by the same thing. Otherwise, it would change the problem. But is that going to fix anything? Yeah. So that's really not going to help me.
Factor out.
Okay. So we have x to the second times 1 plus 2x to the fifth. What are they going to? So with multiplication, that's good, because if we did it in terms of, we can't just plug in infinity to this, because I would get infinity minus infinity, which is 0, which doesn't make sense. Okay? But I can plug it in and do multiplication. So what's negative infinity squared is going to be infinity, right? Negative infinity times negative times negative is a positive. Even if it's infinity, it's still positive. What happens if I plug in infinity over here? But it's negative infinity, right? So it's going to be a negative infinity, which ends up giving me negative infinity, which is my answer.
Yeah.
That's calculus brain. Pre-calc brain, what's the leading coefficient? 2. Leading coefficient is the number in front of the highest degree. So my leading coefficient is 2. What's the degree? 7. So my end behavior states as I'm going to the right, it's going to what? Positive infinity, because it's a positive leading coefficient. Since it's odd, going to the left is going to negative infinity, which is what we're looking at here. So there's pre-calc brain. You also, I know, which is why this is here. You also could literally just graph it and see what's going on. It goes to, yes, it goes down really quickly, but it's going to negative infinity.
So, as it goes to minus infinity, it goes to infinity.
Yes, and as it's going to positive infinity, it's going to positive infinity. That's because the leading coefficient is positive and my degree is odd. So by the end behavior rules you learned in pre-calc, that's true. That's why this one's here. This one was, these two were both horizontal asymptotes. You're not always going to have a horizontal asymptote as you go to infinity. This one's not. This one's going to infinity, which is still a valid answer for your limits. What's this mean? We're looking at 0 from the right side. Why is that important in this problem? And it also can't be negative. So remember, the limit rule states I can do it like this, right? I can find the limit as x goes to 0 of ln of x. I can put the limit inside of my cotangent. So natural logs cannot be negative. So I can't come to the 0 from the left side. I can only come to it from the right side. As I'm coming to it from the right side, what's the value going to? So if you can't figure this out by just looking at it, use a calculator and plug some values in. As remember, that's always something you can do. That's a way. That's the very first method I showed you, right? Just plug in numbers in to see what happens. So we want to get closer to 0. So 0.1 is -2. If I add another 0, okay, we're now at -4. Add another 0, -7. Add another 0, -9, -11, 13. If I keep adding zeros, it's getting smaller and smaller. And it's just going to keep getting smaller. So what do you think it's going to? It's going to negative infinity. We're now past to Google. I have 200 zeros. It doesn't go to 0 very quickly. I mean, it doesn't go to negative infinity very quickly. So we're looking at cotangent of -1 of negative infinity. So the arc cotangent of negative infinity. So remember, what's arc cotangent finding? Right. So this is 1 over the arc tangent, right? In essence. But it's finding it, so that's the value that the angle is going to give you. So which angle on the unit circle would give you negative infinity?
That's not exact.
So as an angle.
You get infinity over there.
You're not getting infinity as the angle. You're getting infinity as the answer. So, and you're right, it doesn't exist, right? The answer, you're never going to get out negative infinity as an answer because that value wouldn't end up existing. So, but we want to look at actually, I'll show you the graph because it's easier to look at it.
Well, you want to look at the right side, right? That's the other one.
No, now we've solved the limit. We've solved the limit. We did the limit as x goes to the right side of ln of x. That goes to negative infinity, right?
Or not. I don't-
So now we want to find out what arc cotangent of the arc cotangent is going to of negative infinity is. It'd be just like when we did this one over here. Remember we found out what was it, cosine of 0? Or sine of 0. We were just plugging in. We've now got a value for that. So as this is our cotangent, right? This is the graph for our cotangent. As it's going to this direction, and it's going to keep going that direction. What do you think it's getting closer and closer to? Pi. So the answer to this question is pi. So now let's look at it in terms of the unit circle so you can see why that makes sense. Just want a unit circle. Cotangent is what over what? X over y, which is sine over cosine. So this would be x over y, right? -1 over 0, which doesn't exist, right? So, but as it's getting closer and closer to 0, this value here is going to negative infinity. As the bottom value is getting smaller and smaller, because it's going from square root of 3 over 2 to square root of 2 over 2 to 1/2. So it's getting smaller and smaller. So as it's getting smaller and smaller, this is getting closer and closer to negative infinity, which is pi. That's where your limits come in. You're looking at it as it's getting closer and closer to that point, because at that point, it doesn't exist. At pi, cotangent of theta or cotangent, arc cotangent doesn't exist. But the value would as you're getting closer and closer to that point. Okay? Does that make sense? So you can do it either way. You can look at it in terms of the graph and figure it out. It's like, oh yeah, that looks like it's getting closer and closer to pi. You zoom out far enough. It gets stuck at 3.14, and you should recognize that as pi, I would hope. Okay. All right, last one. Oh, I'm like, last one, and I didn't put it on the screen. I look over and I'm like, because this screen shows me what's on that one, so it's like, wait, it's not the right spot. What's secant of x? Cosine. So I could rewrite this. Yeah. As cosine of x over x. I could rewrite it like that, right? Okay. Cosine of infinity is not infinity. We can't do cosine of infinity because cosine oscillates, right? So I can't just plug in infinity to this problem. How do we solve this problem? What was one of the other methods that we looked at? Starts with an S. No, that would be just plugging something in. Yes, squeeze. The squeeze method. What do I know cosine of x is between? So cosine of x is between -1 and 1. If I now divide each side or multiply each side by 1 over x, I have that. So now if I do the limit as x goes to infinity of each of these, what's the limit as x goes to infinity of -1 over x? 0. And limit as x goes to 0 of 1 over x is 0. So therefore this limit has to equal 0 because the squeeze theorem states it's between 0 and 0, which means the middle has to be 0.
So what you do is one.
What do you mean the one?
So you change the complete problem to equal.
I just moved the secant up top.
The answer
Is 0. So it's 1 times cosine of x on the top. Do I have to write the 1? No. That's your test. All 10 questions. All right. So you have two options now. You're done. I'm done. I'm done all 10 questions. So if you're good, feel free to leave. If you want help on a specific problem or things like that, stick around and ask. And I will gladly go over I can pull up other questions that are similar to the ones that are going to be on the test, and we can go over those. So, but if you feel you're good, you're good. I will see you on Wednesday. I will be here at 9 o'clock. So you're more than welcome to come in early for the test and start it. And we'll be here till 11:30. So that means you have 2.5 hours to basically do your test, which should be way more than you need. So, okay.
I'm gonna take these two readers.